I'm going to work through problem number 8 from the quiz. You're given the density of tin as being 7.31 grams per milliliter. And you're asked, calculate the volume in kiloliters. Notice I kind of chose a weird unit. Milliliter, liter, we've used those before. Kiloliter. We want to know the volume in kiloliters of 34.77 tons of tin. I gave you density. I also tell you that 1 ton is exactly 2,000 pounds. And I wrote that down as exact, so that way there's no issue with significant figures. And 1 pound is 453.59 grams. So all this information is given to you. So now we need to know how to use it. This is a case where dimensional analysis is actually more useful than remembering this. Density equals mass divided by volume. If you notice, I did not give you this equation. That was not an oversight. At least that's my story, and I'm sticking to it. Because we're going to see that, yes, it's nice to know this relationship, but with dimensional analysis, we can effectively derive this relationship. So here's what we're going to do. We were given density, and that's all fine and good, but the information that we really start with is the 34.77 tons of the tin. You can write the word tin or use the elemental symbol. Doesn't matter. Doesn't matter. Now we draw out a grid. What is the final unit of our answer going to be? Well, that's actually given to you as well. Kiloliter. So it's going to be some number with the unit of kiloliter. I do not expect you to know English to metric units. However, metric to metric, kings have dungeons are in their dark castle moats. Kilo, deci, centi, all of those good units, I expect you to know how to use them. And we'll see that some of the mistakes that I noticed, we're trying to go directly from milliliter to kiloliter. You can do it, but you want to be very careful. I'll show you what I'm talking about. So we have tons of tin. Oops. This is a mass. This is a volume. So we're going to have to do some form of conversion to go from mass to volume. Well, that's easy enough to do when you have density. Our unit is ton, not gram, not milliliter. So we need to find a way to get to grams before we can use that milliliter conversion. Well, again, as it turns out, we've got some information right there. So let's go ahead and use it. 1 ton of tin. Oops. See, this is a case where my mouth is doing one thing, my hand is doing something else. So 1 ton of tin is 2,000 pounds of tin. All right. So tons cancel. Now we're in pounds of tin. Density is in grams, not pounds. But we have this relationship. 1 pound is 453.59 grams. So 1 pound of tin. It's a good idea to always just put that in there. 453.59 grams of tin. Pounds of tin cancel. Now we're in grams of tin. So we're getting really close. We have grams. Our density is in grams per milliliter. So that's very, very good. And this is where you have to be very careful. Milliliter to the -1 per milliliter. So watch what's going to happen. To cancel grams, we have 7.31 grams of tin. Well, if milliliter is to the -1, when we divide, that brings it up here. And I'll justify that in a second. So grams cancel. Use a darker color. So grams cancel. Now we're in milliliters of tin. What I meant by justifying that so if we have x to the -1, that is 1 over x. So if we're dividing something by x to the -1, that's really, in this case, would just be 2x. We flip it over. I noticed some of you, when you were placing grams per milliliter, you actually shove the entire unit in here, not taking into account the reciprocal nature of this. In other words, that it's a negative exponent. So therefore, it's being 1 over it, or dividing by it. And of course, if you didn't do that, that messed up all your calculations. We have a unit of volume, which is what we're trying to get, but it is the wrong unit of volume. Now, this is where you have to be careful. I like to do it this way. You can do it a different way, but I like to do it this way, where I'm going to go from milliliter to liter, because liter, so 1 liter, remember, liter is the base unit. It would be the same thing as if it was 1 meter, or gram. 1 liter is our base unit, and it is 1,000 milliliter. Some of you, I think, tried to do this in your head, and you actually ended up getting this relationship backwards. So if 1 liter is 1,000 milliliters, 1,000 milliliters, so I'm dividing, 1,000 milliliters of tin is 1 liter of tin. Milliliters cancel. Now we're in liters of tin. Well, we wanted kiloliters. You might seem, well, why am I doing it this way? So now what we say is 1,000 liters is 1 kiloliter, right? K, lowercase k, kilo, means 1,000. I could have written this the other way around, but I just want to keep it in terms of the liter. So 1,000 liters is 1 kiloliter. So, in our dimensional analysis, 1,000 liters of tin is 1 kiloliter. And put that off to the side, just to be consistent, of tin. Liters cancel. Now I'm in kiloliters. 1, 2, 3, 4, 5 steps. I know I'm finished because I have the correct unit of measure and everything else is canceled. I wanted kiloliters of tin, and that's exactly what I have. Tons cancel. Now I'm in pounds. Pounds cancel. Now I'm in grams. Grams cancel. Now I'm in milliliters. And this is the conversion. I'll highlight this one. This is our conversion using the density relationship. Okay? This is essentially where we're using this relationship, but we're not doing it by simply trying to plug and chug. We're actually doing it by thinking through, well, okay, grams goes to milliliters, so now in milliliters, that's what I want, volume. So this is me using the density. Milliliters cancel liters, liters cancel kiloliters. So when all is said and done, you will plug these numbers into your calculator, and if you round to the correct number of significant figures, you get 4.31 kiloliters of tin. These type of questions can seem very daunting at first because you're kind of trained from a lot of your other courses of, I got an equation, I got two variables, I rearrange and solve for the third. But in this case, because of unit conversions, you have to go 1, 2, then you kind of use that relationship, 3, 4. So basically 1, 2, 3, 4, 5 steps in total. Only one of those steps is really related to our density equation, even though it's a density-based problem. So if you did not get this correct, go back through with a blank piece of paper, retry the problem with the correct information in front of you. Simply watching me do it is not going to be good enough. You need to be able to think this way because dimensional analysis is a problem-solving method. It's not simply a let's just plug numbers into the equation and shoot something out and see what happens. It's all about what is the proper unit of measure that I'm going to end up with. And some of you actually left off the units of measure as you were doing this, and not unexpectedly, you might have got 1 or 2 steps right, but then when you didn't have grams or pounds written in, your next steps were inverted because you didn't have a way to cross out the units. So you're essentially flipping a coin, deciding should I multiply by 1,000 or divide by 1,000? Should I multiply by 7.31 or divide by it? Again, units will help you out here. They'll tell you exactly what you have to do. Otherwise, you're literally just flipping a coin.